Hi, my name is Kajetan, and I'm presenting to you our paper, It's About Time, Adopting Theoretical Constructs from Visualization for Sonification. My co-authors are Alexander Rindt, Michael Iber, Robert Höldrich, and Wolfgang Eigner. Let's get right into it. This paper is part of the research project Sonivis. In Sonivis, we try to develop a design theory for the combination of sonification and visualization for exploratory data analysis. This graph shows how we imagine such a system to work. Our expectation is that a human analyst will have better chances to find structures or patterns within the data if they are able to use both their senses, their visual sense and their auditory sense, at the same time to analyze their data. In order to develop a design theory, it's very important to have a common language to describe the design space of those combinations. The visualization community has developed theoretical constructs that help them to describe and discuss their designs. In this paper, we adopted these theoretical constructs for the domain of sonification. With the help of these two visualizations, I'm going to introduce the theoretical constructs. The space that is used by a visualization is called the spatial substrate. The spatial substrate holds the marks. The marks are the entities of perception in a visualization, and they can be distinguished by their dimensionality in their substrate. So we have zero-dimensional point marks, we have one-dimensional line marks, or two-dimensional area marks. Sometimes you can find volumetric marks, but they are not very common. A third construct is the construct of the channel, in this case the color or the position of a point mark. In our paper we adopted the construct of the mark and the substrate to the domain of sonification to be able to then discuss combined designs with this new language. Let's start with the substrate of sonification. If we would think of space as the substrate of sonification, then we could think of mono, stereo, surround, and spatial audio as the different mark types. But the system has major drawbacks. One of them is our ability to localize sound in space. Our ears are far worse than our eyes in localization in space. A second argument is that space is not indispensable for auditory objecthood. That means that it's not important from where a sound reaches me, but what sound reaches me for me to identify it. So let's try something else. How about time as the substrate of sonification? There are several arguments in support of time as the substrate of sonification. In sonification, we position sounds in time just like we position visual marks in space. And while our auditory sense has not the best spatial resolution, its temporal resolution is amazing. So let's use time as the temporal substrate of sonification and space as the spatial substrate of visualization. The follow-up question has to be, how many auditory mark types are there, and how can we define these auditory marks? In sonification, we usually deal with two situations. One of them is when we use sounds that represent data as a state in time. We call those sounds zero-dimensional auditory marks. The second situation is when we use sounds that represent the data as a development over time. And we call these one-dimensional auditory marks. We're not searching for a 2D or 3D auditory mark because time as a dimension is not providing a second or third dimension. You can compare these definitions with the point mark that marks a position in space and the line mark that marks a position and a development in space. Let's listen to a few examples of auditory marks. Here you can see the visual representation of a one-dimensional auditory mark. When we listen to the sound, you will hear a development over time. Imagine that this development directly represents a sorted data set. For example, stock market data. It's the temporal development of this sound that makes it one-dimensional. Let's also listen to a 0D auditory mark. In this case, it's not a temporal evolution of the sound, but its harmonic structure that conveys an information. A sound with this harmonic structure could convey a different information than some sound with another harmonic structure. But also this sound is considered to be a zero-dimensional auditory mark. In this case, there is a temporal evolution, but it's not informative. It's only important when in time this sound happens, but not how exactly this sound develops over time. Let's sum up what we found so far. The substrate of visualization is space. The substrate of sonification is time. The different mark types in visualization can be distinguished by their dimensionality, from point marks up to volumetric marks. In sonification, we distinguish zero-dimensional auditory marks that represent data as a state in time from one-dimensional marks that represent data as a development over time. This system allowed us, or will allow us, to use one common language for both visualization and sonification, and hopefully also for the combination of those two systems. In the end of this presentation, let's talk about a few parallels between visualization and sonification that emerge with this system. First of all, the formation of Gestalten is a parallel. The dotted line is the perfect example. If you think of a dotted line, every dot, every point, could represent a zero-dimensional visual mark. But the combination of those dots will trigger the perception of a line phenomenon. The same is true in sonification. Here you could think of the granular synthesis. When you put many grains next to each other in time, this could trigger the perception of a temporal development, so a one-dimensional auditory mark. Another parallel is that visualization has to deal with spatial clutter, and sonification has to deal with temporal masking. Thank you very much for listening. I'm sure there are many open questions. I'm happy to answer some of them.